In section 8.2, we'll talk about perimeter of polygons and then how that can be used to help find the area of polygons. So the perimeter is the distance around the outside of a polygon. So for a triangle, the perimeter is when you add all three sides together. If it happens to be an isosceles triangle, you know two sides are equal, so you'd multiply. Or you can just do A plus B plus C if you want, just go around outside the circle. But if you wanted a different formula, knowing that you have two of the side lengths that are the same, you can use that formula. Or how about an equilateral triangle? All three sides are a certain measure. You can just multiply one of the sides by 3. But of course, you can always just still add up all three sides if you get used to that procedure. And then how about the perimeters of different types of quadrilaterals? Well, if it's a scalene quadrilateral where none of the sides are equal, you just have to add up all 4 sides. But how about if it's a rectangle? The perimeter can be 2 times the base plus 2 times the height. Or you could call it 2 times the length plus 2 times the width if you want. Or how about if you have a square or a rhombus? That's where all 4 sides are equal. We're just going to do 4 times the side length. And so for any parallelogram, we know opposite sides are congruent. So 2 times one side plus 2 times another side, adding up all the sides. However, it's more important to understand the concept of how to find perimeter rather than just memorizing formulas. The ability to go around the outside of a polygon and find the distance for perimeter. All right, so here let's look at this example here. Here they want us to find the perimeter of triangle ABC if. So for our first scenario, AB is 5, AC is 6, and BC is 7. So for here, our perimeter would be 5 plus 6 plus 7, or our perimeter would be 18. And perimeter is a linear unit. It's just inches, or just centimeters, or just feet, not squared. All right, but how about scenario B? In scenario B, they tell us that AD is 8. And we're told BC is 6. So from here to here is 6. And what do we know about that altitude is? From here to here is 6. That side is going to be 3. And we are told that AB is perpendicular to AC. So here I have a triangle with, if I can find the area of this smaller triangle, I could multiply it by 2. Or if I can use this triangle to find this side length. Let's see. Well, this is a right triangle. So let's try to find C. We know that C squared is going to be 8 squared plus 3 squared. So C squared is going to be 64 plus 9. So C squared is going to be 73. So C is going to be the square root of 73. So this side over here is the square root of 73. All right, and so that's perpendicular. That's going to bisect that side. The area of this triangle, I'm sorry, the perimeter, I'm getting ahead of myself here. If this is the square root of 73, then this is the square root of 73, so my perimeter is going to be 2 times the square root of 73 plus 6. And if you were to put that in your calculator, that would be 23.1 centimeters. Not centimeters squared, just centimeters. There's another very interesting way to find the area now of a triangle. It's easier to find the area of a triangle if we know its base and we know its altitude. But what if it's not a shape that's easy to find a base and an altitude? There's always Heron's formula. And Heron's formula is a way to calculate the area of a triangle, but it involves finding the semi-perimeter. Semi meaning half. So the semi-perimeter is 1/2 adding up all the sides. And then Heron's formula says that the area of the triangle is the square root of the semi-perimeter times, and then the semi-perimeter minus each of the 3 sides. That's Heron's formula. And we're going to practice that. What if I was asked to find the area of this triangle? There are no right angles. There's no real easy way to find out what the lengths would be if I were to try to draw an altitude. So I'm going to use Heron's formula. So what's my semi-perimeter? The semi-perimeter is 1/2 of 4 plus 13 plus 15. So half the perimeter, semi-perimeter, is going to be 4 plus 13 plus 15, that's 32. So my semi-perimeter is 16. So Heron's formula says the area of this triangle is going to be 16 times 16 minus 4 times 16 minus 13 times 16 minus 15, all under the square root. So the area of that triangle is going to be the square root of 16 times 12 times 3 times 1. So that means the area is going to be the square root, using your calculator, the square root of 576, which is going to be 24. And since we're not given the units, we're going to say units squared. That's your area. All right, so how about when the lengths of a quadrilateral and one of its diagonals are known? So here's a quadrilateral that does not follow a standard rule. It's not a square. It's not a rectangle. But as long as I have the length of one of the diagonals, I can use Heron's formula to find the area of region 1. And I can use Heron's formula again to find the area of region 2. And so the area of the quadrilateral would be Heron's formula for the first plus Heron's formula for the second. And kind of akin to Heron's formula is Brahmagupta's formula. Brahmagupta's formula is used to find the area of a quadrilateral whose all 4 vertices are on a circle. This would be called a cyclic quadrilateral. And so the area would be the square root of the semi-perimeter minus one side times the semi-perimeter minus the second side times the semi-perimeter minus the third side times the semi-perimeter minus the fourth side. Notice we don't have the semi-perimeter by itself in Brahmagupta's formula. just the difference of semi-perimeter and all four sides.